This is lesson P.2. Most of it is talking about exponents. It also has some review of scientific and decimal notation. Here's the assignment. Notice that it's every other even, and that for simplifying exponential expressions in that section, leave your answers with all positive exponents in them, no negatives. That's very important. Okay, so what are negative exponents? Negative exponents essentially say, hey, this base is on the wrong side of a fraction. So if you have 5 to the negative 3, that whole thing is on the numerator side of a fraction. Once you move it down to its correct position in the bottom, then you can change the exponent to a positive. So that's now 5 to the third in its correct position on the bottom of a fraction, which can be simplified to the overall fraction of 1 over 125. Notice that I didn't have the top of the fraction once I move this down here. If ever there's a number that's missing, you can always use a 1. So that's what we have, the 1 at the top. Down here we have a complete fraction where the negative exponent is on the base of the denominator. We can then move that up to the numerator. Now, since we don't need the top placeholder of 1 anymore, we can throw that away. You could think of also as just multiplying anything by 1 once you get there. Either way, you end up with 4 squared on the top part of the fraction. No denominator is left, which is just simplifies to 16. The zero exponent rule basically means that anything that you attach a zero exponent to turns the entire expression into a 1. So negative 3 to the 0 power was 1. All this stuff, if the entire term is raised to the 0 power, it becomes 1. It doesn't matter how complicated that is down there. Okay, simplifying by grouping same base powers. If you have 4 to the 5th times 4 to the 2nd, basically 4 to the 5th means 4 times 4 times 4 times 4 times 4. And 4 to the 2nd is 4 times 4. So you have a group of 5 4s and a group of 2 4s. And if you put them all together in one large group, how many 4s do you have? 7. So 4 to the 7th. Now this seems simple, but it really, really, really will help you if you can start seeing exponents like this in your head. Because sometimes things get more complicated. Here's an example of something slightly more complicated. If you have 3x squared y to the 4th all raised to the 5th power, basically that means you have 1, 2, 3, 4, 5 groups all multiplied together of 3x squared y to the 4th. And then once you have this all written out in groups, you can take it in pieces. You can take the 3's together. 3 times 3 times 3 times 3 times 3 is 243. You have a group of 2x's, a group of 2x's, a group of 2x's, a group of 2x's, and a group of 2x's. How many x's total? Should be 10. So x to the 10th, and so on with the y's. 1, 2, 3, 4, 4, 4, 4, 4. How many groups of 4? You have 5 groups of 4 y's, which is 20. Now dividing powers is a little different. Here I have m to the 5th and m to the 3rd. Again, if you think about m to the 5th as m times m times m times m times m, and m to the 3rd as m times m times m, then it's easier to understand exactly what's going on here. Basically, we can cancel on the top and the bottom any pair that is exactly the same value. So what happens is 3 of our m's on the top cancel with the 3 on the bottom, and we just get left with m times m. Since that's the numerator, we don't need the fraction anymore, and we simplify to just be m squared. Down here, 2/7 to the 3rd power. Well, what is that 3 really saying? It means that you have 3 groups of 2 to the 7th, or 2/7. So 2/7, 2/7, 2/7. On the top, we have 2 times 2 times 2, which is 8. And on the bottom, we have 7 times 7 times 7, which is 343. Here's a more complicated example. Let's do some of our own. Okay, if I want to simplify 2x to the 3rd y squared all raised to the 4th power, that means there are 4 of these. So I'm going to write that out. 2x to the 3rd y to the 2nd 2x to the third y to the second, 2x to the third y to the second, and 2x to the third y to the second. Okay, so there's 1, 2, 3, 4. Okay, so basically I can go 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Now, how many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a group of 3, group of 3, group of 3, group of 3. So that gives me 12 x's. I have 1, 2, 3, 4, 5, 6, 7, 8 y's, because I have 4 groups of 2. Down here, there are no exponents that are outside the parentheses, but we can certainly just multiply the numbers that are alike. Negative 6 times 3 is negative 18. X squared times x, there's a group of 2 x's and another one gives you 3. Group of 5 y's and a group of 3 y's gives you 8 of them total. If you see them all written out in your mind, it's easy to just simply count them out. Simplify the expression, but we don't want any negative exponents. Okay, well let's take it one section at a time. We can divide 100 by 20, which gives us 5. On the top here I have 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. On the bottom I have 6. 1, 2, 3, 4, 5, 6. And again, I can do this just in my mind, but if I cancel 1, 2, 3, 4, 5, 6 of the x's, I have 3 left over on the top. So that's 5x to the third. Now the other one is a little different. We use that different technique of saying, hey, I've got a y to the negative 4, which means that I can move that part up to the other side of the fraction, which puts it on the top. And then I get to change it to a positive exponent. So on the top I have 2 y's and another 4 y's, so that's a group of 6 y's altogether, or y to the 6. Now the last one is a little tricky here on this page. Basically, this negative exponent can be applied both on the top and the bottom. And what does a negative exponent mean? It means the thing's on the wrong side of the fraction. So this whole thing goes to the bottom and change the exponent to positive. This whole thing goes to the top and change that exponent to positive 2. So y to the 4th squared is y to the 4th times y to the 4th. 5x squared is 5x times 5x. So I have a group of 4 y's and another group of 4 y's. So that's a group of 8 y's altogether multiplied. And then 5 times 5 is 25. X times x is x squared. Now notice that they wanted all positive exponents. I've done that in both cases.